All right, next we are learning about absolute value applications. So a common application of absolute value linear equations involves modeling situations in which a tolerance is given or a limited range of values is accepted. And so here they just give you some pointers on how to do these problems. You're going to identify or calculate the midpoint or the tolerance. I always think of this as the goal. So if you want to write that above, or we could even put that right in here, this is kind of the goal of the problem. It's what you're trying to achieve. And then the max distance from the midpoint. So that's how far you can vary from your goal before you have to reject the situation or reject, maybe you're talking about packaging a product or something like that. So this, the max distance, or how much you can vary. So, all right. So if you are given the minimum and maximum values, like how far you were able to value like the absolute maximum, the absolute minimum, you could get away from that goal, then you can find the midpoint of those. You can find the average of those to get that and that goal or that midpoint. The max distance from the midpoint is half the difference of the max and min values. So you can find that distance as well. So we'll look at examples of those in these notes. So that's kind of the first step, is to identify those values. Second step is to write the equation in this form: x minus the midpoint equals that distance you can have, solve the equation, and then kind of check the reasonableness of your solution. So basically describe your solutions in context. So one thing I always say is that a story problem gets a story answer. So these are real life context, real life in quotes, because some of them don't really make a lot of sense, but we'll write our answers in sentence form, basically. So here, the first example says the listed weight for a loaf of bread is 400 grams. So if that's the listed weight, that's basically the goal. So this is our goal right here. This is our, see, the word midpoint in this case doesn't really make a lot of sense to me, which is why I say that's the goal. So if we're going to claim that the bread is 400 grams, are we going to get it 400 grams 100% of the time? No, probably not. So now we're going to figure out a range of values that are acceptable if we are claiming that our bread is 400 grams. So here, the bread can actually vary by up to 24 grams and still be considered acceptable. So they want us to write an equation representing the minimum and maximum loaf weight that is going to be acceptable here. So we're going to say x minus our goal, so x minus 400 equals the amount we're going to allow it to vary, equals 24. And I'm going to define x just so I don't forget what the x actually represents, so I can keep in mind what it actually means. So x is the actual weight of an individual loaf of bread. So whatever we end up having, x is the actual weight of an individual loaf of bread. I was going to spell bread with an O. I'm not sure where the O is going to come from. Okay. Now you can probably solve this equation intuitively. It can vary by 400. 400 is the goal. It can vary by 24. We need to take 400, go up by 24, take 400, go down by 24, and then we can get our minimum value and our maximum value. So you're welcome to do the math that way. I'm going to go ahead and I cannot think of the word right now. I'm going to give you guys some extra practice in solving absolute value equations. I'm going to reinforce, that was the word I was looking for. I'm going to reinforce how we solve absolute value equations. So if you guys remember, Once the absolute value sign is alone on one side of the equation, then we do two versions of it. We do the negative version. Oops, not in the parentheses, not yet. We do the negative version equals the number. And we do the positive version equals the number. So is this the easiest way to solve this problem? No, but I just want to make sure you guys remember how to solve absolute value equations. So I'm distributing the negative. I get negative x plus 400 equals 24. I'm going to solve for x by subtracting the 400 over. I get negative 376 when I do that. And then I can go ahead and divide the negative 1 over to the other side, and I get x equals 376. Over here, I can add the 400 to the other side, and I get x equals 400. And so those are my two solutions. Gracious, when you add 400, you do not get 400. Add the 400 to the other side, and you get 424. X equals 424. There we go. Okay, those are my two solutions. So this is my minimum value, this is my maximum value. So that means that the actual weight of an individual loaf of bread needs to be somewhere between these two values. So we're going to say the minimum acceptable weight for a loaf of bread is 376, the units were grams, and the maximum is 424 grams. Okay. So now, if we look at the next problem, it says a grocery store sampled the weight of their loaves of bread, and they had 405, 409, 378, 360, that one's a problem. 422, 374, that one's a problem. 402. Which loaves of bread should be rejected? So 360 is definitely too small. 374 is just a little bit too small, but it's still too small. The people who got those loaves of bread would not be happy. Those loaves of bread would be, this one probably visibly too small, this one maybe not so much. Visibly too small, but it wouldn't be fair. Those would be too small. So the loaves weighing 360 grams and 374 grams should be rejected. They're too small. All right. Example 2. A national TV variety show televises performances each summer. The producers require that the acts are between 1.5 and 2 minutes long. So 1.5 is the minimum value, 2 minutes long is the maximum value. So we have 1.5 is our minimum, 2 is our maximum. Those numbers are manageable enough that we can already tell what the middle point is. So the midpoint of these is pretty easy to find, but let's go ahead and actually use a mathematic formula to do that so that if we run into a problem that is more difficult, we can use our notes to do it. So to find the midpoint, or to find the goal value, we're going to take the two values, 1.5 and 2, we're going to add them together and divide by 2. So this is what the notes were talking about above when it said the midpoint could be calculated by averaging the maximum and the minimum values. So adding them together and dividing by 2. So here we've got 3.5 divided by 2. and 3.5 divided by 2 is 1.75. So that's the goal value. Okay, so then the max distance from the midpoint is half of the difference between the maximum and minimum values. So we're going to say the difference between these were 0.5 apart. That's the distance between those. And so this distance between them divided by 2 is 0.25. So that's how much they're allowed to vary by. That's how much they can vary by, is the distance between the max and the min divided by 2. So the equation we're going to have is x minus the midpoint, which is 1.75, equals how much they're allowed to vary by, which is the distance between them divided by 2, so 0.25. All right, you don't have to do this part down here because we're doing these notes at home, not in class. All right, on the other side of the page. So this one is another type of application problem that we might do. So this is how you calculate the percent error of something. It's experimental value minus theoretical value divided by theoretical value. And then you take the absolute value of that, so if it's negative, force it to become positive, and then multiply it by 100. And this is going to give you a percentage. Percent error calculations are used to compare actual data to theoretical data. It quantifies how closely the real-world applications of something aligns to a theoretical value. So how close is it? All right, the boiling point of water in Denver, Colorado is 203 degrees due to its elevation above sea level. While in Denver on vacation, Carissa measured the temperature of the water to be 204.7 degrees when it started boiling. What is her percent error? So we're going to say her percent error is, so her experimental value is 204.7 minus the theoretical value is 203 divided by 203. We're going to multiply that number by 100. Okay, so I'm going to go ahead and just type this in on a calculator. So I've got 204.7 minus 203 divided by 203. That gave me a positive number, and I'm going to multiply that by 100. And I get 0.837 approximately. I'm rounding that, so I'm going to say this is approximately 0.837%. All right, and I'm going to go ahead and leave that last problem for us to finish in class together so that we can do one example problem together and so that you guys can ask some questions in class if you need to.